This is Essentials of Strength and Conditioning, Training and Conditioning, third edition. We're going to go page 94, Anaerobic Training. Anaerobic training consists of high-intensity intermittent bouts of exercise such as weight training, plyometric drills, and speed and agility, and interval training. In certain anaerobic training programs, anaerobic metabolism is also highly involved and therefore concurrently trained. Performance adaptations to anaerobic training are specific to the training program. As a result, improvements in muscular strength, power, hypertrophy, muscular endurance, and motor skill performance will occur. Some exercises that stress the phosphagen system, sprints and plyometric drills, are under 10 seconds in duration and provide almost complete recovery between sets, 5 to 7 minutes, to enable training at maximal intensities. Speed and power training depend greatly on optimal neural recruitment for maximal performance and high training quality, which requires recovery and minimal fatigue. Glycolytic conditioning uses shorter rest intervals during high-intensity exercise. Integrating these two metabolic demands is vital because many athletes must be able to perform under fatiguing conditions in competition. Yet each metabolic component also needs to be trained specifically for optimal results. The aerobic system has limited involvement in high-intensity anaerobic activities, but is more involved with recovery of energy stores. In addition to the demands of training, the metabolic demands of each sport and practices also contribute to the adaptations accompanying anaerobic training. Critical physiological adaptations to the nervous, muscular, connective tissues, endocrine, and cardiovascular systems enable an individual to improve athletic performance following anaerobic training. Adaptations range from those that take place in the early phase of training to those that take place through years of training. The majority of research has typically dealt with adaptations in the early to intermediate stages of training, 4 to 24 weeks. Understanding how the individual systems of the human body adapt to physical activity provides a knowledgeable base from which the strength and conditioning professional can predict the outcome of a specific training program. All right, now we're going to neural adaptations, still page 94. Anaerobic training may elicit adaptations along the neuromuscular chain, beginning in the higher brain centers and continue down to the level of individual muscle fibers. An increase in neural drive is critical to the athlete striving to maximize strength and power. The increase in neural drive is thought to occur via increases in agonists, those major muscles involved in a specific movement or exercise, agonist muscle recruitment, firing rate, and the timing and pattern of discharge during the high-intensity muscular contraction. A reduction in the inhibitory mechanisms from the Golgi tendon organ is also thought to occur. Although it's not clear how these mechanisms coexist, it is apparent that neural adaptations are complex and typically occur before structural changes in skeletal muscles occur. Let's see, we'll do central adaptations, page 94. The ability to increase motor unit activation begins in the motor cortex with the intent to produce maximal levels of muscular force and power. The primary motor cortex activity increases when the level of force developed increases and when new exercises or movements are being learned. A substantial proportion of the neural changes that occur during anaerobic training take place in the spinal cord along the descending corticospinal tracts. Untrained individuals display limited ability to maximally recruit motor units, especially fast-twitch units. Electrical stimulation has been shown to be more effective than voluntary activations in eliciting gains in untrained individuals or in those rehabilitating from injury, further indicating the potential inability to successfully activate all available muscle fibers in certain physiological conditions. A study by Adams and colleagues using magnetic resonance imaging showed that only 71% of muscle tissue was activated during maximal effort in untrained individuals. However, training greatly reduced this deficit, thereby demonstrating a greater potential to recruit fast-twitch motor units. All right, and that is page 97. So that's page 94 to 97. That was central adaptations and neural adaptations. See ya.